So what we did yesterday, that if we express different masses in grams, then it will be just called mole. So what is the definition that you can see on the screen? The bookish definition: the atomic mass, molecular mass, or formula mass, when expressed in grams, then it is called 1 gram mole. All right? What the mole is? Mole is the SI unit for the quantity of a substance, to find out the amount of a substance. Okay? For example, if you have half glass of water, then a normal person will say it contains 100 gram water, but the same quantity of water will be calculated or will be used in chemistry in terms of mole. The scientist will say that this glass contains this much of moles of water. For a common man, grams. For a scientific, for a chemist will use the term mole or gram mole. All right, what is the symbol of mole? M-O-L. So we did it yesterday. For example, what can you see on the first line? Water, H2O. Remember, if you were absent, if you didn't attend the class during the last 3 or 4 days, you won't be able to understand whatever I am telling it to you. Okay? Until you are intelligent enough to understand. Water, its atomic mass is 18. All of us know. If we represent this 18 AMU in grams, then it will become 1 gram mole of water. 18, what is 18? Is the molecular mass of water. If we double it, instead of having 18 gram of water, if we have 36 gram of water, obviously it will be 2 gram moles. If it is 54 gram of water, 3 gram mole, and so on. Similarly, you can see on the screen sodium. The first one was the example of molecule, a compound. The second example is sodium. It is an atom. It has atomic mass. What is the atomic mass of sodium? 23. If you represent it in gram, it will be called gram atomic mass, 23 gram. So, by definition, if you represent molecular mass or atomic mass in gram, then it will be called mole. Since it is one atom, that is why it is called 1 gram mole. If instead of having 23, we have 46 gram, you will call it 2 gram of sodium atom, 2 mole of sodium atom. So remember, mole itself doesn't have any particular value. It depends on the name of the compound. 1 mole of water means 18 gram. 1 mole of sodium means 23 gram. 1 mole of carbon dioxide means 44 gram. See how? Carbon dioxide, CO2. The mass of carbon is 12. The mass of oxygen is 16 times 2, 32, 44. So this is its molecular mass. If you represent it in gram, it will be called gram molecular mass. 1 molecule of carbon dioxide, its mass is 44 gram. Scientists call it what? 1 mole. If it's double of it, 88, you call it 2 moles. Okay? So see another example on your screen. O is the symbol of oxygen. What is the difference in these three? O, O2, O3. This is oxygen atom. This is oxygen molecule, because we have studied that atoms combine together to form a molecule. This is O3. What do you call O3? Ozone. Very good. So its mass is 16 AMU. Its mass will be 16 to the 32. Its mass will be 16 to the 48. If you represent them in grams, gram atomic mass, gram molecular mass, gram molecular mass, 1 atom of oxygen. So it will become 1 mole of oxygen atom, 1 mole of oxygen. Can you guess what will I write next? Oxygen molecule. And 1 mole of ozone. You can see on the screen same. See the difference by yourself. Suppose if I say 32 gram of oxygen atom, then it will become 2. Okay? So mole means simply the atomic mass, the molecular mass, or formula mass expressed in gram. And what was the formula to find out the number of moles? You can see the formula. So let's see 2 problems. Question. Calculate the number of moles in 500 gram of sugar. What is the question here? We have to calculate the number of moles in 500 grams of sugar. So first of all, what will you see? That what is given to you and what is asked? This, if you write, this will be called data. So what is given to you? Some sugar. How much? Correct? 500 grams. So we'll write here mass of sugar. What is the formula of sugar? C12H22O11. All right? Let me write it. C12H22O11. So my given mass of sugar is 500 grams. What is asked? Calculate the number of moles. Number of moles is to be found out. Same pattern that we did during the last minutes of yesterday's class. Okay? So how many of you remember to find out the number of moles? What is the formula? Number of moles is equal to given mass upon atomic or formula mass. So given mass you have, but you don't have its formula mass. So first we will find out its formula mass. So under the heading of solution, we'll write first First, we will find the molar mass of sugar. Sugar C12, H22, O11. Now, if you are not aware of finding the molecular mass, it will be difficult to you. Okay, what is the atomic mass of carbon? I told you it will be given to you. The atomic mass of carbon is 12. And how many carbons do we have here? 12. So 12 is the atomic mass and 12 we have over here. What is the atomic mass of hydrogen? 1. How many hydrogen do we have? 22. What is the atomic mass of oxygen? 16. How many oxygen do we have? 11. 12 12s are 144. 122. Only 22. And when you multiply these two, it will become 176. Adding all of these, it will give you 342 grams. You can also show this in the rough work, but it is better to show under the heading of solution. Okay? Now you can find the number of moles. Formula. What is the formula? Number of moles is equal to given mass upon atomic or molecular mass. What is the given mass here? 500. What is the molecular mass? 342. 0.4. Number of moles is found to be this much. In the last, you will write the result that 500 gram of sugar is equal to this much moles. 1.46 moles. Okay, let's change the question a little bit. You can make your own questions just for your own practice. I'm changing this number. The next question, that was question number 2. Now question number 3. One we have did yesterday. I've changed the question. Calculate the number of moles in 200 gram of carbon. So what is given to you here? Mass of carbon. How much carbon do you have? 200 gram. What is asked? Number of moles. Can you guess the difference between this question and the previous question? This one is easier. Think, what is the difference between the last one that I wrote, sugar, and here I just write, what have I written, carbon? Yes, in sugar, we have to find its molecular mass. We did it over here. First we found the molecular mass which comes out to be 342. And what is the difference here? Carbon. Carbon is not a compound. It itself is an atom. So there is no need to show this step. Means the mass of atomic mass of carbon will be given to us. So we can also write it in the data that the atomic mass, gram atomic mass of carbon is given to you. Where you can find it? At the end of the paper. Means it is given to you. It will be given to you. All right? So here comes the solution. So no need to show those steps to find out the molecular mass, because what is the change in the formula? Yes, clever students. What is the technical change that we should show over here? Number of moles equal to given mass upon atomic mass. Okay? So what is the given mass here? 200. What is the atomic mass? 12. Just divide them. So the number of moles you can write it directly 16.66. Okay? Look at the board, look at the screen. There is someone who is watching you right now. Who is this man? He is Mr. Avogadro, Italian scientist. Right? Look at the board. Look at the board. H2O. Its mass is 18 AMU. Showing it in gram. 18 gram water. 18 gram water means that you have a glass. In this glass, you have taken 18 gram of water. It contains water molecules. It contains water molecules. How many water molecules? Okay, one more thing. How many moles? 1 mole. Look at the board. Carbon dioxide. Very important. Carbon dioxide. How, if someone asks how many moles, if it's written like this, you'll say 4 moles of carbon dioxide. How many moles of carbon dioxide? 2 moles. How many moles of carbon dioxide? 1 mole. How many moles of water? 1 mole. No number is written as a coefficient. It means 1. So this is 1 mole of water. So 1 mole of water means 18 gram. We have taken 18 gram water. Now if you count how many water molecules, small water molecules, tiny water molecules are present in it, you will find that it contains 6.02 into 10 to the power 23 molecules of water. What is this 6.02 into 10 to the power 23? What is this? C. 6.02 into 10 to the power 23 means 21 zeros. Means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? 21, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This is written in short form like this. So this water, this much quantity of water contains so many water molecules. If we take sugar, C12, H22, O11, 1 mole of sugar. We just found out its weight. How many? 342 gram, less than half kg. If we take 342 gram of sugar and we start count that how many sugar molecules it contains, okay, then we will find naturally it will contain the same quantity of molecules. If we take 1 mole of carbon, what is the mass of 1 mole of carbon? 12 gram. If we take 12 gram of carbon means a piece of carbon like this. This is a piece of carbon. Then it will contain 6.02 into 10 to the power 23 atoms. So what was found? That 1 mole of each and every substance contained a fixed number of particles. If you have 1 mole of water, it will contain this much quantity. 1 mole of sugar, 1 mole means, what is the point here? 1 mole of any substance contains a fixed value of particles, means atoms, molecules, ions. That number is called Avogadro number. So that is why you can see the definition. The number of particles in 1 gram mole of any substance is fixed and is known as Avogadro number. Okay? Its value is 6.02 into 10 to the power 23. It is represented by capital N, small a. So whenever you see N and capital A as a subscript, it will be representing what? Avogadro number. You can see on the screen the Avogadro constant is named after the early 19th century, in the honor of the scientist 1811. And who proposed this? Jane Perrin. Just for your info, that what does this number, how can you read this number? Read point number 2 and 3. So quite interesting. It's a very, very huge number. What is, I'm changing the slide. Okay, so it's a very huge number, very, very huge number. And this number, so much quantity is present in just a small quantity of water. It means the size of atom, the size of molecules is very, very small. That is why only 18 gram of water contains these molecules, this number of molecules. Just for info that how can you find this, how scientists were found that number? By Millikan's method and by X-ray technique. Next class, we will continue solving the numericals of moles and Avogadro number. And this will be your assignment. Assignment will be available to you on Google Classroom also. Solve problem 1 and 2 on page number 22 in your book. Okay? That's all for today. If you have any question, do let me know in the group, or you can just message it to me or email it. Thank you so much.
Okay.